Welcome to the Explainer. So today we're tackling something that is just deeply relatable. I mean, if you've ever spent hours scrolling through a massive, totally tangled block of code, trying to figure out why a single button click is causing total chaos, well, you are definitely not alone. We've all been there. Let's see how we can finally escape that messy spaghetti code and master the absolute elegance of the state design pattern. Okay, let's dive into this. Here is our roadmap for today. First, the problem with conditionals. Then, modeling the state machine, and third, the state pattern structure itself. After that, we'll walk through a TV remote example, look at an online order system, and finally wrap up with exactly when to actually use this pattern. Starting with part one, the problem with conditionals, or as we all know it, the if-else nightmare. So when we start checking if an order status is new, and then if it's paid, then shipped, the real problem isn't actually the if statement itself. The real issue is that all this state-specific behavior gets concentrated into one single massive place. It's like a giant dumping ground. As you add more states, you inevitably pile on more conditions. That means more and more responsibilities are crammed into one extremely fragile file, making it incredibly hard to maintain. You literally have to look at this code and ask, wait, who should actually own this behavior? To fix this, we need a complete mindset shift. Forget the syntax for a second and just ask yourself, what behavior changes when the object's state changes? Think about it. If pressing a power button does something totally different when a TV is on versus when it's off, well, that's a massive clue right there. We're dealing with state-driven behavior. Moving on to part two, modeling the state machine. Basically, thinking visually first. Before you even think about writing a single class, it helps so much to just map things out visually. If you trace the flows of a simple TV remote, you can clearly see how the system flows seamlessly from off to on to mute based on very specific actions, like pressing the power or the mute button. And once you have that visual graph, it translates beautifully into a clear logic table. Notice the core equation here. It's basically a current state plus an action equals a specific behavior and a next state. So to put that into perspective, if our current state is off and the action is pressing the on button, the behavior is turning the TV on and our next state becomes on. It's clean, it's totally predictable, and best of all, it leaves zero room for those weird, ambiguous bugs. Part three, the state pattern structure. Let's look at the architectural components. Okay, so this UML diagram is essentially your ultimate blueprint to escape conditional hell. There are four absolutely crucial elements to understand here. First, the context. This is the object the client actually interacts with, like the TV itself, and it maintains a reference to the current state. Second, we have the state interface, which defines the common operations. Third, the concrete states. These are your actual classes, like off state or on state, that implement the specific behavior. And fourth, the client, which sets the whole shebang up. The absolute magic here, the context just holds the current state, but those concrete states do all the heavy lifting. This before and after contrast is where the paradigm truly shifts. Before, our context was just packed full of if-else logic, basically having an existential crisis asking, which state am I? But after the pattern is applied, the context just delegates. It holds the state object and calmly asks, current state, what should I do? Honestly, it's brilliant. Delegation completely replaces interrogation. So the golden rule we can pull from all this is simple. Move behavior that changes with state into objects representing those states. Instead of one giant TV class trying to play God and control absolutely everything, you hand that responsibility over to dedicated off, on, and mute objects. Let's move to part four, an example, the TV remote. Time to see how this builds and apply the rules. Take a look at the runtime flow. Our TV, which is our context, is created and its initial state gets set to off state. Now, when a user grabs the remote and presses on, the context doesn't run some messy if check. It simply forwards the request to the current state object. The off-state object handles it, prints TV turned on, and then crucially, it changes the context state to on state. The context never once checked its own state. It just blindly trusted the state object to do its job. Let's break that execution down step by step so you can clearly visualize this delegation happening in real time. Step one, the context receives the request from the client. Someone presses a button. Step two, the context immediately delegates that request to whatever state object it currently holds. Step three, that concrete state executes the actual behavior. And finally, step four, if a state change is needed, the concrete state tells the context to transition to the new state. It is just a perfectly choreographed dance. Part five,
The online order system. Let's see about scaling the pattern.
Think about the life cycle of a typical online order. It starts as new, moves to paid, then shipped, and finally delivered. Or, it could be canceled along the way. Think about a standard action like pay. If the order is new, pay processes the payment and transitions the state to paid. Easy. But if the order is already shipped or delivered, calling pay should probably just return a message saying, already paid, or maybe throw an error. The exact same action behaves entirely differently depending on the state. That makes it a perfect candidate for the state pattern. Now, what's really interesting here is what happens when business requirements inevitably change. Let's say your manager runs in on a Friday afternoon and says, hey, we need to add a return state. Without the state pattern, you're diving back into a massive class, adding new else if blocks everywhere, and totally risking breaking existing code. But with the state pattern, you literally just create a single new class called return state. You define its specific behavior, plug it in, and you are done. Adding a completely new state requires almost zero modifications to your existing classes. It's just incredibly robust. Finally, part 6. When to use it. Let's go over the practical checklist. Here is a quick, practical checklist to keep in mind. This pattern is absolutely perfect when an object's behavior changes significantly depending on its state or when new states are very likely on the horizon. But, and this is important, the documentation gives a clear warning. Avoid it if you only have 2 or 3 simple states. We definitely do not want to over-engineer our code and turn a super simple if statement into a complex family of classes. Keep it simple if the problem is simple. At the end of the day, the crucial point is really about delegation versus interrogation. I want to leave you with a bit of a challenge as we wrap up this explainer. The very next time you open up a massive file full of nested conditional blocks, look at your code and ask yourself, are you asking which state am I instead of simply commanding current state what should I do? Changing that one perspective might just save your entire architecture. Thanks for joining me on this explainer, and I'll catch you in the next one.